When you use a cool new AI application, it can feel like pure magic, right? But what's actually happening under the hood? Well, today, we're going to pull back that curtain. We're going to deconstruct a really clever AI productivity assistant and see how all that magic is actually built on some seriously solid logic. Let's follow one simple command on its journey, from start to finish. All right, so what are we looking at here? Imagine a personal productivity assistant, your own little sidekick that lives right in your command line. And here's the cool part. You can give it those super specific by-the-book commands, or you can just talk to it. And that's where things get really interesting. I mean, just look at this. You type a simple human phrase like, show me my tasks, into a terminal. The one place on your computer that's usually super picky, super literal, and completely unforgiving. And it just works. It actually understands you. So that's the big question, isn't it? How on earth does a computer go from this plain English sentence to a concrete, useful action? That's exactly what we're going to unpack. We're going to trace the entire journey of this command through the system's architecture. Okay, so the official title for this project is an AI-first personal productivity assistant, but the key phrase to focus on is dual mode. You can think of it as an app that speaks two different languages. One is the precise, perfect language of code, and the other is just normal, everyday conversational language. So let's look at those two modes. On one hand, you have the structured, manual command line interface, and on the other, you have this flexible, AI-powered natural language mode. Both get you to the exact same place, but they take completely different roads to get there. And you can see it right here. On the left, it's totally explicit, right? Program, action, parameter. Very structured. But on the right, it's just a conversation. You're just telling it what you want to do. And yet, they both achieve the exact same thing. It's like having two different doors that lead into the exact same room. And this brings us to an absolutely crucial design principle for this project: feature parity. It's a simple idea, but it's so powerful. It just means that anything you can do in one mode, you must be able to do in the other. There are no secret, AI-only features. And this is key because it ensures the tool is consistent and reliable, no matter how you decide to use it. So how does the application actually manage these two totally different inputs and make sure they do the same thing every single time? Well, the answer lies in its elegant four-layer architecture. This is the engine room, folks. This is where the magic gets translated into pure, simple logic. Let's break it down, and honestly, the best way to think about it is like a restaurant kitchen. Step 1, user input. Is the customer placing an order? They can either point directly to an item on the menu, that's our manual command, or just tell the waiter what they're in the mood for, that's our AI. Step 2, the action resolver is the head chef. They get the order and know exactly which station needs to handle it. Step 3, the CRUD functions are the line cooks. They're specialists. They only know how to create, read, update, or delete tasks. And finally, step 4, the in-memory store is the pantry. It's where all the ingredients, our data, are kept. That kitchen analogy is perfect for understanding the concept, but how does it actually translate into code, into real folders and files? Let's take a look at the project's blueprint and see how this elegant design is organized. And this is just beautiful. It's so clear. Each one of those layers we just talked about has its own folder. The user input is split neatly between the CLI and AI folders. The resolver folder, that's our head chef. The core folder contains all those reliable workhorse functions, our line cooks. And storage is the pantry. It's clean, it's organized, and it's incredibly easy to understand. Now, just to give you some perspective, here's what the backend for a more common web application might look like. You see all these other moving parts: folders for databases, authentication, routing. The point is that good architecture is always tailored to the job. This assistant's design is beautifully simple because its task right now is simple and focused. So we've seen the what and the how, but now let's talk about the why. Why go to all this trouble to separate everything so neatly? This is where we get into the principles of building smart, reliable, and maintainable software. This quote right here is probably the single most important idea in the whole project. AI orchestrates, CRUD functions execute. Think of the AI as the conductor of an orchestra. It decides what needs to be played, but it doesn't play the instruments itself. It just points to the trusted, human-written functions that do the actual work. This is so important because it prevents the AI from just making up and running its own unpredictable code. So it all comes down to a clear set of rules. The AI only calls functions that have already been written. The layers are independent and stay in their own lanes. Storage is kept in memory to keep things simple for this first version. And get this, There are almost no external dependencies. This isn't just about writing code, this is about disciplined engineering. And why does that discipline matter so much? Because it leads to software that is reliable, easy to maintain, and simple to test. By limiting the AI's role to just orchestration, you create a system that's predictable and safe. You get all the power of AI without the risk of chaos. Now, what we've seen today is just phase one. But this clean, logical architecture isn't just for today, it's the foundation for everything that comes next. So that leaves us with a final, exciting question to think about. What happens when this assistant gets a permanent memory? What happens when it moves to the web? That's when all of this solid groundwork is really going to pay off.